Hello, friends. Hope you all are doing good. I'm welcoming you to our learning series, which I had started on design of hydronic systems. So, in the same series, today we are going to discuss about what is the hydronic system and what all are the basic component of the hydronic system in central air conditioning plant. So, let's start. In this particular video, we are going to understand what all kind of pipings are there in any central air conditioning plant and how all these piping need to be configured along with the walls, pumps and other accessories. So how it is really important, what kind of value add these systems and components are adding in the efficient operations of any central air conditioning plants is going to be detailed out. So here you can see what all are the basic components. So the basic components are source, wherein the equipment is installed to actually reject the heat. The second is the pump, third is the load, and the distribution system, which I was talking about. So here there is a terminal unit, which is called air handling unit or fan coil unit, which has been installed. It carries the heat through the load equipment, which is there, air handling unit and fan coil unit, and this heat is being distributed through the distribution system to the chiller or any hot water generator for heating applications. And after rejecting the heat to the atmosphere to the cooling tower, is again going to come back. The chill water or the hot water is going to come back to the air handling unit or the fan coil unit. And there's an expansion tank, which is called expansion chamber or expansion tank. So these are the basic component of any hydronic system. So in the hydronic system or any central air conditioning plant, water is used to carry the heat from point of generation, such as cooling or heating, which I had explained, to the point of heat rejection, such as refrigerant machine or hot water generator or the chiller for the cooling or dehumidifications. So here you can see there is a coil, a fan coil unit or air handling unit, and this particular heat from the point of generation, the heat where heat is being generated in the room, is being carried to the chiller or a hot water generator, and then it has been rejected to the condenser, and the condenser is rejecting heat to the through the cooling tower if it is a water cooled, and if it is air cooled, then directly to the environment. So this is a typical configuration wherein any heat which is generated at the source end is being rejected to the fan coil unit or air handling unit, and then finally that heat is being absorbed by the water and transferred to the evaporator and from evaporator to the condenser and the cooling tower. For heating or the hot water coil is the same. Instead of chiller, there is a hot water generator. Water is going at 120 degree Fahrenheit at a differential of 20 degree Fahrenheit, delta T of 20 degree Fahrenheit for the inlet and outlet. The heat is being absorbed and again coming back to the hot water generator. So this is the difference between heating and the cooling circuitry for any hydronic distribution in central air conditioning plant. So water is used to condense the refrigerant to liquid, and thus it transports the heat of condensation to the cooling tower for the rejection into the atmosphere. So here we have seen the heat which was being absorbed by the evaporator through refrigerant, it has been transferred to the condenser, and the heat of condensation has been transferred to the cooling tower, and because of the evaporation, cooling towers reject the heat and cold water again comes back to the condenser, and the cycle continues. So this is a typical arrangement from generation to the cooling tower, how heat is being rejected. So this is a typical distribution system wherein the mechanical plant room is there when the chiller or the hot water generator has been placed, which is called the high side. And on the low side, there is the FCU fan coil unit. There is a air handling unit in the block. In the other wing, there is a air handling unit. So these are the air handling unit and fan coil unit. So there is a supply header from which the air handling unit or the fan coil units are connected, and these are connected at the load end. So the heat which is being rejected or the generated is being taken care and taken to the plant room wherein the chiller, cooling towers, and the pump are being installed. So this is called the chill water supply and the chill water return. And on the cooling circuit, I have already explained. So in this particular system, you could have seen actually the water is working as a secondary refrigerant. So the primary refrigerant, which is the refrigerant there in the chiller, here water is working to transfer the heat or to absorb the heat as a secondary refrigerant. So what all qualities any secondary refrigerant should have? So let's understand. So any secondary refrigerant, what are the necessary attributes? It should be cheap. It should be easily available. It should be non-toxic. It should be non-inflammable. It should be stable in operating range, operating temperature range. It should be generally non-corrosive, suitable for ordinary material. Viscosity should be low so that the fluid could be pumped at the minimum energy cost. So hope you have got an insight how hydronic distribution should be configured and why water is adding a great value add in terms of as a secondary refrigerant. So if you do have any question, any comment, or you are working on any of your project, put your queries in the comment box. I have already prepared a few of the videos which is talking about constant constant system, constant flow system, primary variable, primary secondary variable, distributed pumping system, and all. I will also share the link of all of these video in the description, which will make you easy to run through all those videos also. So subscribe my channel. We'll see you in the next video. Thank you.